Okay, we're going to be doing functions now. This is chapter 6 in Gaddis, 9th edition. Functions are a very, very important feature in programming. Functions are about taking an idea and breaking it up into modular parts, into small little parts, each part doing its job. So you have this guy, this guy, this guy, this guy. They each do their own job. Functions are supposed to be small. Like a function in Excel, you get to take something like sum, and you pass in information, it sums it, it spits it out, right? There's two different types of functions. There's a void, which doesn't return anything, and then there's a function that does have a return statement. Two different types of functions, which we'll discuss, but in general, you have a tough, big problem. You break it down into little bitty parts. Each part does its job, and that's the idea of why a function is so powerful, because you get to use it. Now, main is a function over here. Main is a function. Main has a return type. It returns 0, and it has a name, and it has parameters. Now, I can make other functions as well. Like I can have a function called void, means it's not going to return anything. I'm going to have a void display num, display, okay? And it's going to say, it's just going to see out less than in function 1. That's all I'm going to say, and \n. Okay, so that's all it does. Void will be a function. It's outside main, as you can see. It's outside main, and it could have its own variables that would only exist in it. But void is a function that is going to, it's a type, the name is display. We didn't pass anything into it, but it's just going to display that. So if I wanted to say display, okay, what is it going to do? It's going to call the guy outside main. It's going to call that. So if I say debug and start without debugging, let's get this moving. Oh, you know what the issue is? I always forget to do this. It's a function prototype. If you have a function, you could put it in front of main, but otherwise it doesn't know that it exists. When it hits display, it says, what is that? So what I really have to do is just copy. I can just copy and paste the name right there, up there. And now this is called a function prototype, which says that when you start the program, get the includes, make sure you know what's out there. The void display tells me know what's out there. Okay? So you just put the name of your function up there whenever you do it. I always forget to do it. But in function 1, that's what it says. So it's in function 1. When you run this, it could be in function 1. Now, I could have a number, I'm going to have another void. I'm going to have void display more. And it's going to be cout in function 2. \n. This is going to be in function 2, and I'm going to actually have this function call the other one. So this is going to call display more. Okay. So what's going to happen here? You know, a little bit of nesting. Main, and I'm going to again put the function prototype on top. Control-C, put it up there because you need to tell the program that it's there, that it exists. So main is one function. You can make it so you can see less and more at the same time. But main is one function, and it calls display. Display says I'm in function 1. Then it calls display more. And display more says I'm in function 2. And then I'm going to have in main cout back in main \n. Okay, so that way we can know when it gets back to main. So if I run this, I have my headers. It's going to say in function 1, in function 2, back in main. Okay. So you can have as many functions as you like. They can each do a different job, which is the nice thing. But notice that let's create some variables. So in main, I'm going to say int I. Actually, first I'm going to pass in something. I'm going to say int I equals 6. And I'm going to say display I. Now, in my display, I'm going to have to tell it to display something. So I'm going to say int x. Okay? And what that's going to do is it's going to use x. So I'm going to just display x, in fact. I'm going to display x. by saying cout x in my function. Now, in my my function prototype, I also have to say int in order to tell the compiler what is the function prototype. So up here, where I have display, because that's the thing, it now actually has something you can pass in. So what's happening here, step by step? Int I equals 6. I is being passed into display. Display takes I, it calls it x, but who cares what it calls it? And it says cout that thing that you passed me, which is x. So in other words, I'm going to cout the 6. I'm going to pass that out, and you can see when I run this that I have display more there, which I have to erase because I already erased that. But you can see that when I do run this, debug, start without debugging, it's going to now say 6 because it passed in the 6 into I, into display, and then it used it. Now we could do math with that. Like you could say something like x equals, or let's just say x plus plus, okay? Now back here, I'm going to display, I'm going to cout I end line, okay? So this is what's going to happen. I is going to be set to 6. It's going to be 6 is going to be passed. Oops, 6 is going to be passed to display. Display is going to take in 6. That's how it takes it in. It takes it in by having that argument there is taking it in. It's going to add 1 to it, and then it's going to display it as 7. But back in main, 6 never changed because the scope of it is something that never changed. So we have a parameter in here, but the parameters in here don't affect the parameters in here. So we'll see that if I were to run this, it's going to say 7 because that's what 6 was added, something was added to it, and then 6 because back here it's actually is back again to be 6. So we have this as different functions. In void doesn't do anything to it. It just, you could cout, you could do stuff, you could have something that you like. And we can pass things into this as well. Now, what I would like to do is I would like to have a way to really do something with my function. So I'm going to erase all these guys over here. I would like to have a way that not just that it just displays something. I'd like to have something like a return statement in order to do this. So what I'm going to do is I'm going to create a different type of function, which is going to be a return statement. So I'm going to say double average int a, sorry, we'll say double a double b, and those are going to be the 2 arguments that are going to be passed in. Now average is going to take the 2 of them, it's going to add it together, then divide by 2. So I'm going to say int double c equals, and it's going to say a, just do some math, a plus b, and it's going to say divide by 2. And then I'm going to say return, because this is a different type of function. This actually returns something. This is going to return c. So here's my function. It averages 2 things. Now, why don't I average any number of things? Okay, I could, but let's just start simple. It's outside main, and it's of type double. Of type double means that's the return type. That means the return is going to be of type double. That's what we say double in front means. It means that the return is of type double. And what I'm going to do next is I'm going to say average is the name of the function, double A is the type of thing you're passing into A, double B is the type of thing you're passing into B. We add those 2 things up, we divide by 2, and we're going to set that equal to C. And it's going to return C. C is of type double, so it actually returns something. So let's create some things to return it. So I'm going to say double test1 equals 86.4, comma test2 equals 96.4. And I'm going to then say double answer equals average of test1 comma test2. So it's going to take those 2 tests in. This is what the program does. It's going to take the 2 tests in, and it's going to say double test1 equals 86.4, test2 is 96.4. It's going to pass in test1 and test2. Now, in the function, it's called A and B, but that's okay because A is now 86.4, B is 96.4. It can't change test 1 and test 2, but it made a copy of it. It passed it by value, so it made a copy of it. And it's going to add them together, save it as C, and return C. Which type is C? Of double. So it's going to say average is going to return whatever C is. So it's going to double. Answer is now going to be saved that way. Now we're assigning whatever the return statement is to answer. I could also just say cout, whatever that is, because that's a return statement. It's going to actually return something. It's going to return something. So if I say debug, start without debugging. What did I forget again? Function prototype. So I'm going to highlight this, Control-C, put it above main, and put a semicolon at the end of it, and now everything will work. So I just threw this up there because that's my function prototype, which is the name of the function, basically, so that way it knows it exists. So it added it together, it figured it's 91.4, and that is the average. So I was able to call this function. Now here's the benefit of functions. Anywhere I want, I can call a function that's called average, and I can pass two things in, and I can get an answer out. And that's number one. So I can call it multiple times. I don't have to rewrite any code. I can just call average whenever I want. That's number one. Number two, I can break down my problem to something very small, and I can do each part of the problem separately. Okay, that's number two. Number three, the function is isolated. You called average, but you don't know how average works. You don't know the details of average. Okay, encapsulated. There's a lot of words and terms here, but you don't know how average works. You just know that it does. You can't see the implementation, but that's good because that means it's protected. So those are three very important things about functions. One, that they are isolated, the implementation is isolated. Two, that we can call it again and again and again without having to rewrite the code. Like we can show that we could just, hey, you could call average, do it in four, and three, that you can break up your problem into something very, very small. And each different step along the way, you're able to break up your problem and to do that. So we could also have, let's do odd and even again, okay? So I'm gonna erase my function. Of course, I could leave many functions in here, it doesn't matter, but odd and even is gonna actually return a bool. It's gonna return a Boolean, so that's the first thing here. So bool, odd or even, and the name of the function is going to start with the lowercase, but it's going to have, I'm going to erase my other one there, but it's going to have, each next word is going to be uppercase. So you're going to pass in int num. You're going to pass in something that we're going to call number when we're running this. Now, I'm going to say if num mod 2 equals 0, if that is 0, then what I'm going to do is I'm going to say return true because it's even, right? Now, who says that that's what I should do? Now, I just wrote it slightly differently, but okay, if num mod 2 equals 1, then what I want to do, I want to say return false. Okay, so that's perfectly legal to have this type of thing, that I have two return statements in here. And let me get my function prototype up there, Control-C, and put that up there. So when I run bool, it's going to return either true or false. There's two return statements, but that's okay. True is going to be even, and it's going to be odd. So this is a return statement, so it's going to save it as something. So I'm going to give myself a number, int test num equals 57. Ooh, that's a scary one. Is that a odd or even number, 57? Right? Ooh, my kid is learning about in pre-1A right now, odds and evens. He said if it has a pair, then it's odd. Then it's even. If it doesn't share a pair, if it doesn't have a friend, doesn't have a partner, then it's odd. I asked him, so the small numbers he was okay with, but big numbers, so we'll try and get him to understand what it means to be mod 2 at some point. But int test num equals 57. If num mod 2, so let's run this and let's call odd or even, and let's say something like cout odd or even, and you can see you can just press tab when you do that, and I'll pass in test num. Okay, and I will then do endline in order to do that. So what's this going to do? It's going to test whether it's odd or even, and I have two return statements, but that is perfectly fine. It's perfectly fine to have two return statements. Let me run it. Start with that debugging, bada bing, bada boom, 0. Okay, so what was 0? 0 is false. Now you should pay attention to what these things are, but you know, it's a little bit unclear because, you know, who says it's odd or even? I should have said even, that it would be true or false, you know, that way. But that's okay. In general, the function name should be, the function should be short and it should be direct, but it should actually have a name that tells you clearly what the output is. And you could do this, but in general, it's better to, you know, have one output and make these things very succinct because you want to know what you're doing 10 days later or 5 minutes later when you do this. Let's create another function, and it's going to return the radius. It's going to say double get. It's going to say I'm going to have a get radius. Okay, get radius is actually going to be a void because it's not going to actually do anything. So I'm going to say void. And it's going to, the get radius is actually just going to return the radius will, sorry, the get radius should be a double because it's actually going to return the radius. So all I'm going to say is return, let's do get area because that'll be a little more sensible until we do objects. Okay, so get radius, and you're going to pass in double radius. Okay, so double get area, double radius. The return type is going to be a double. The name is get area, and you're passing in something that's a double called radius. What am I going to return? I'm going to put this all in one line. That's why I was hesitating to do it, because I want to do it all in one line rather than break it up. I'm going to say, what's radius? It's 3.14. What's area? 3.14 times radius times radius, because it's radius squared, right? Times radius. And that's okay too. You could just have a return statement, as long as you spell things right, have a return statement that's going to do that. So if I want to run this, I could say int radius, double radius equals 9.81. And then I can call my function and say double area equals get area of radius. And you could pass in numbers as well. I'm just trying to do it. Now notice that we use radius up here and we used it in the name. But that doesn't matter. It doesn't matter if you use the name of radius in both, because it's really two separate things. Because like we said before, this is just a name for when it makes a copy of it, how it's going to deal with it over here. It's then passing it back and making another copy to pass it in. So it's passing by value over here to do this. So you get stuck with, and again, make sure you make your function prototype. I'm going to copy this. I'm going to paste it up here. And now I could use this if I wanted to. You actually could say without the name, you could just say get double. Just double get area double. What are these? The return type, the name of the function, the thing you're passing in with its return type, and what you're going to call it, like an alias. And this is the return statement because it has a double, because it has a return. If it didn't have a return, it'd have a void in front. A void is when it has no return statement. Now, we saw that radius and radius are two different things that are going to get stuck there. So you could make things available to everybody, like we've said before, and you can have global variables and constants and stuff like that. So I could say something like int radius equals 5. Okay. Now it says that this is okay, right? And I can have const as well. Const diameter, for diameter b, for a separate one is going to be equal to 10. Now, when I say const, I actually have to tell it what type it is, and I'm going to leave this as a int as well. Now, these would be accessible to everybody. The only thing is, though, that I have radius right here. So which is the one that it's going to use? It's going to use the one that's the local variable, not the global variable. So if you rename it, which you shouldn't do, you shouldn't make global variables and then use them everywhere, because you might end up using the same name. But it will do something called shadowing, which is actually going to use this value over here. to run this. So let's see what we get if we run it. I'm not promising later on we don't, but let's see what we get. Nothing, because I didn't see out it. So let me see out area, less than n line, and let's see what we get. We get 3.302.181. Why? Because it didn't choose 10, it didn't choose 5 as radius, right? Let's do something so it's clear. I'll make that into something bigger, so that way it'll be clear. And 302.81, because it's choosing radius as the local variable, even though the global variable is something that everybody can access. It's choosing it as the local variable, and then it's passing it in. So even though I have it like 5 times the same word in this program, which is obviously bad programming practice, it's something that we should be aware of. Now, let's look at some examples. Let's look at some examples of stuff. All right. This is an example from Gaddis. This program uses a reference variable as a function parameter. Ooh, I don't want to start there. I'll start here. This program uses a static local variable. So this is our function prototype. It's called ShowStatic. We have a for loop, which is going to be in main, which is going to just do ShowStatic a couple times. It's going to do static 5 times, 0 to 4. Okay. ShowStatic, you could also do comments like this. I never told you that, but you could do comment with this just 1 or 2 is okay, and that's where it starts and ends. But void ShowStatic, this is a void, so there's no return statement here. So you can see there's no return, it just does it. So this is just how it calls it. Void ShowStatic, static int num call 0. So static means that it's not gonna, static means it will remember what num calls is every time, no matter what and where and whomever. It knows what num calls is. So static allows it to be static, which means that you don't recreate it every time you every time you use ShowStatic. In my program, whenever time I use getArea, it's recreating this whole thing to return. But over here, it's not. It's actually keeping num calls as it knows it. So it's going to say, see how this function has been called? And then it's going to say plus plus num calls. So it's going to say 1, because num calls was 0, it's going to add in 1 times. However, because it's a static int, it means it's next time it does the loop and it's going to remember what static is, what the num calls is, because it was static. So then it's going to be 2, then 3, then 4. So you could see when I run it, it's going to say, I'm running the wrong program. Let me go run this in main. Okay, let me get rid of this. So let me run this in main. And I even have a function prototype. And it says, 1, 2, 3, 4, 5. That's because it said static and it remembered it. If I get rid of the static, it's not going to remember this variable. And when I run this, it's going to say 1, 1, 1, 1, 1, 1, 1. This is called 1, 1, 1, 1, 1, 1 times, because it didn't remember the variable. Static allows you to remember the variable and know it, and so therefore it's going to be saved, kind of, quote unquote, as what it is. So obviously there's problems that you can run into doing this, but it's something that is not terribly unreasonable. Example of a void area which has some default arguments which are built in over here. Okay, in main, I'm going to call area, and it's going to have 3 arguments. A is 1.0, 3.0, and 1. In over here, I have my arguments x, j, and z. X, j, and s is just going to multiply x, j, and s. If I were to call area as is, it's going to give me a 1, because it's going to be 1 times 3 times 1, because it doesn't use the default arguments unless I tell it to. But if I were to call area with no arguments, then it will say 105, which is using the default arguments. So you could, the first instance you have, you put in your default arguments, and that is a way to ensure that you can have default arguments which don't necessarily need to be used, but are available to you if you would like. So you could have area with multiple parameters or some parameters. You know, you could say comma 5.0, comma 19. That would take in 2 parameters and leave the other one blank over there. That's the idea. that it's that you're actually able to do that. But this, in this fashion, would actually be an illegal call to do it this way. So let's just do it with a 5 in here. And if we say 5, let's see, ooh, let's just make it 10 just to change, make it different. And so if I do this, it's going to say 220 because it's replacing the first one. So you can see there are some, details here, like you can't just replace any of them. You can only replace it, number by number. But this would be a reasonable way to use a function, which now has possibilities, like we're showing, to call it in different ways with however many parameters you're actually interested in calling it with. So the defaults will be there, and then you could put 2 parameters, but once you can't skip the first parameter, essentially. That's essentially the idea. So it would be illegal, like we showed, with that to do it the other way, but void area could be that way. Now, let me make void, just to show you, okay? I'm going to make void into a double, as a double return. It's going to actually return something now instead. Okay, it's going to return a double, so I'm just going to say return x times j times s. All right, and that's fine. I'm going to just do x. I'm just going to actually say return x. Okay, just to make this life simpler, I'm going to chop out everybody else over here, and I'm just going to say return x, and double area is only going to have an x in there, and it's just going to return x. Okay, you don't even need to say that, but double area is there, and I'm going to say something like double k equals area, and you're going to put in 50, and it's just going to return 50. Okay, so it just returns 50. And I say, why am I doing this? Well, the reason is because I want to show you something. There's this thing called overloading operators. That means that I could create another function with the same name, and it's going to take in what might look like the same thing, but it's going to return a different type. It's going to actually return an int. So I have one function that returns a double, and I have one function called area, which takes in an int, which it could take in other things, but it takes in an int and it returns it. So this is area with a double. So if you called it with a double, it would pick this one and do it. And if you called it with an int, it would pick this one and do it. So if I had it assigned to the area, and I'm going to say 50.01, I know which one that's going to go to. But if I were to say int j equals area with a 40 there, okay, with a 40 there, I know which one it's going to call here. I'm going to actually just make this x times x, so that way we are actually showing something. And I'm going to see out that, in fact. Okay, so I'm going to see out this over here, see out this, so that way we can see it with an end line. And I'm going to see out the other one as well with an end line. Okay, and get myself an end line there. And now, let's see what happens. When I run it, it's going to say, dun, 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 for 50.01, because the first one returned that, and the other one multiplied it. So there is our great idea, which is we could create something with overloaded operators. Now, why you say, well, why are you doing that? The function with the same name. The reason is because it's a really important tool in order to make sure that somebody who's using our function can return whatever data type they'd like, because maybe we have a function, it needs to return different data types. So it's, when you get into real programming, you run into these types of issues that you want to use that idea. Okay. There's this idea called a parameter that is going to have an address. The address of operator is this, okay? So void double num int address of ref var. What that means is it's going to reference the address of something. Now you say, well, what does that mean? Let me tell you. I'm going to erase this stuff so we can see this all together. Okay. Value is 4. In main, value is value, 4. Now calling double num. Double num is right here. What does it do? It takes in value. Okay, it takes in value. Void double num int ref var. It's going to be passed by reference. So it's going to take in 4, and it's going to do something to it. Ref var is going to be times 2. Now, it's a void, so it doesn't do anything, quote unquote, doesn't return anything, But because we have this address of operator, when you passed in value, ref var wasn't really just a copy of value of 4. It was actually just referencing the address of value. So whatever you do to ref var, that's going to look at the address of value, and it's going to do the same thing there. In other words, whatever value is now going to be changed because it can look at where it lives. It's like I don't want to get into everything, but it's where it lives. It's the address of operator addresses the thing you're passing in because it's passing a reference to it, which is saying now I can go look at the thing you passed in and I'll change that as well. So now back in main, value is going to return the double of it. In other words, it's going to return 8 even in main. Because even though you'd say, oh, value is the scope is only in main, you're passing something else in here. No, I'm passing something that references, you say ampersand ref var, it references the place that you told me to, which is what you passed in. And so when you try and do something to ref var, it's actually going to change the original data point, which is nice because then void has some meaning, like you can actually do something by changing the original data point. Okay, this is a big deal, okay, because you can now change the data point. All right. So this program reads a set of daily high temperatures from a file, displays them, and demonstrates how to pass a file to a function. The function argument, which is a file stream object, must be passed by reference. Okay, once we're talking about passing by reference, which is the ampersand, okay. So void read file, it's going to be this is a function called read file. This is a function prototype up here because it's a head. It's an input file stream. It's going to be a reference. It's going to, okay. So in main, we create the input file stream, the name is input file. We open weather.dat, and then we say if input file.fail, then don't do it. Else read file input file, okay? Read file input file. Well, what's read file? Read file is a function. It's going to pass an input file, which is the opened guy there. It's going to pass it in. And then it's going to do input file.close. So let's see what happens when you pass it in. What happens when you pass in read file? Let's make this clearer. Why is it doing that? I don't know. Okay, we'll leave that as the else there. Okay. Now, here is read file. Read file says take in some file, but not some file as a name, some file as the address of whatever you pass me. What type am I? I'm the if stream type, the input file stream type. So you're going to pass in, what'd you pass in? You passed read file, you passed in input file. So now I can look at the address of input file and I can do things to that address. What am I going to do? Right? Because what do you mean the address of it? It means the original data point, in other words. While some file, which is really input file, is going to be able to read temperature, it's going to do that while that's true, right? We saw that while that's true, while that's something, then just see out temperature end line. So it's going to output each different spot in temperature. But to do this, we need to have the ampersand here because it has to reference the original data type, the original object, which is the input file stream of input file that opened it. That is the one in control. So it's not, when it read file, you're passing that in, but you're actually passing a reference to it over here in order to understand what's going on there. It has to understand, to be able to read that thing. Okay, let's go to some examples now. Okay, bunch of examples. A quadratic formula over here. Main is right here. Main, so if you want to apply the quadratic formula, this would be it, and you would do that. Okay, now you could put this into a function instead, and it'd be no problem. Okay, it'd be no problem to put this into a function. How would you do it? You just put these instructions into a function, meaning this is the instructions essentially. You need an A, B, and C, and you put those into instructions and do that. Let's now look at just a different, we did that already. Okay, calculate squares. We want to do functions. So these are functions already. Okay, main is over here. Main is going to say the square of n is square n. That's the function that you're going to call. What is it? It's going to say int square n, and it's going to take answer. It's going to take x, multiply it by itself, return it as answer, and it's going to output it. It's an int. The type is int, which means that's a return type. Perfect. Int is an answer, so it works. It's going to take in that. The name is square. Now, why isn't there a function prototype? Because, not necessary because it's above main. So it's not necessary it's above main, but this just takes in a number n is 5, for instance, takes it in, and it squares it for you, and it passes n to this function. Okay, draw a triangle. Now, we did this before, but here's main. Main says how many rows, saves it as rows. Okay, it says for star through stars less than rows, call spaces and then call stars. Spaces is going to go call this function spaces, and it's going to say a loop of however many spaces, 1 to x. Okay, that's because you told it how many spaces to do, so 1 till x. And then it put a bunch of spaces in the console, and then it calls stars. And then let's see, stars is going to call a certain amount of stars, which is going to be 1 to x as well. Okay, so it's going to do this and call the rows minus stars, really, is what you're passing in, because it's going to be, or let's say there was 10, so it's going to be, let's say it was 1, the other one's going to be 9, then you'd have 2 spaces and 8 stars, then 3 spaces, then 7 stars, etc. But it does this, and it does this however many times it's supposed to do it, because this is the rows going down, and this is the this is across the columns. This is calling spaces, however many spaces, and then calling stars. So you should try and understand what this is, but essentially it's first seeing how many spots to do, and then filling the rest in over there with that. So pretty neat. Triangular numbers. We did this before as well. It's just a loop. Triangle, it's going to do a for loop in main calling triangle. C is going to be 1, 2, 3, 4, 5. What is that going to be? Int answer equals 0. It's passed in, let's say, 1. For C is 1 to 1. Answer plus equals C. It's going to output that. Return answer is just going to output that. And if C were like 5, it would do from C equals 1 up until 5. It would go from 1 to 5. It would add it all together, return answer, and then it would output it. Again, it's above main, so it doesn't need to have a function prototype. But this is a great example. Okay, let's now break up our prime factoring that we did and break it up also into functions, right? We're breaking up everything we had into functions to understand it better. We already did this in previous videos, but now we're going to break it up into functions. Okay, enter a number, give it to me. If n is small factor, then that is prime. What's small factor n? Okay, well, that's the number you gave me, and I'm going to go see. Let's see, small factor int x. Int answer equals 2. Now, while x mod answer is not 0, answer plus plus. In other words, cycle through answer being 2, 3, 4, 5. So 7 mod 1, 2, 3, 4, 5. If it's not 0, in other words, like 8 mod 2 is 0, then it's gonna keep going. Otherwise, it's just gonna return answer. So if it returns n is equal to n, in other words, if it returns 7, because 7 mod 7 is going to be the 0, so then it will say that is prime. But if it's not, because it went through 8 and it returned to 2, so n is not equal to 2, it's going to say that is not prime. That's a very interesting code. It's very worthwhile to look through this and try and understand it. Okay, let's get out the factors of numbers. Okay, it's going to basically be using the same code. Enter a number, and we're going to get a number. Now we have a number. While n is positive, while n is greater than 1, int f equals small factor n. Small factor is a function. It's going to do it, and it's going to be assigned to f. Let's see what's going to happen. Let's say we had 21. Okay, 21. So small factor of 21. Let's go see what small factor does. It says the same thing as before, actually. It says x mod answer, and it's going to return it. So if I passed in 21, when will x mod 3 is going to be 0? So it's not going to, when x mod 3 is not equal to 0, so it is. So then it's going to return 3. So small factor is 3, that's going to be f. F is going to be c-outed. Then 21 divided by f is going to be 7. And then we're going to run this again and get 7 is a factor of 7. So you should try and understand how this works. But we're using the same code we did before to check what the factors are, and this will get the smallest factor out every time because it's going to do the mod starting from 2 up until some number, and then it'll just divide the number out of that factor over here and then just call it again because we're in a while statement. So it's going to keep calling small factor, getting out the smallest factor every single time. Beautiful, beautiful thing. So we draw diamonds. Nah. Square roots. This is a very good one, but I'm not interested in explaining it. Call by reference, super important here, okay? Main says enter a quiz score, C in quiz, add 10 quiz. What does that do? You pass in your quiz score and it's going to do something to it. Void add 10. It's going to say int pass in the address of quiz score of quiz, and it's going to take it and it's going to add 10 to it. So it's not just going to do it here, it's actually going to add 10 to the address of it, which means the quiz, which is what you passed in, now will have 10 added to it. So when you display quiz in main, it's going to have 10 added to it. We didn't want to just do it here. If we didn't have the ampersand, it would just do it here. But then we'd be stuck because it didn't do anything in main. But if you pass in the address of it, it actually looks at what you're passing in. You passed in quiz, n is just the address of quiz, so it's really going to do whatever it doesn't end is going to be at the address of quiz. So therefore, it's going to change quiz. Okay, this is great example as well. Main is going to be 4 and 6. Let's see, should we swap it? It's 4 and 6. Swap 4 and 6. Okay, let's see what swap does. It's going to switch x and y, so that way it's going to be 6. X is going to be 6 and y is going to be 4. But let's see. Take the address of A and address of B, the two things you're passing in, x and y. Take the address of those things, and then int temp equals A. Set a equal to some temp. So 4 is going to be temp. Then B, which is 6, is now going to be assigned to spot A, because A is being held, 4 is being held in temp. B, what's in B, because we're talking about the address everywhere, right? B, which was 6, is now going to be assigned to A. Then temp, which was holding the 4, is going to be assigned to B now. So the temp was like a little holder in order to do it. Now, because you say, ooh, what did we do? Because now A and B are switched, but we didn't do it in main. We did, because A and B are the address of it. So every time you're switching something with A and B, you're actually switching the x and y in main, because that's what you passed in. Because this is the address of x and the address of y over here. So you pass A to temp, B is going to be assigned to A now, so B is assigned to x. Then temp is going to be assigned to B, so temp is assigned to y. So that will switch them, and there you have a swap, which will change the address of these things as you go. Okay, you could order two numbers as well using this. So let's see, main. Main says order xy. All right, main says order xy. So that code that we just saw says void order. Now, what does order do? It takes in x and y as the address of x and y and calls if A is greater than B, then swap. So it's now going to call a different function called swap. And it's going to take in the address of that and then swap them if need be, and then come out of here and then go back to main and do that. And we just saw the swap using the temp. Okay, and you could do ordering 3 things as well. And you would have to do it this way with order xy, then order yz, then order xy. Think about that, but it's the same functions that are swapping because they're swapping the address of each of those. So you're swapping x and y, seeing if it's order, then you're swapping y and z, seeing if it's order, then swapping x and y again, because the z may have changed it and shifted it. So the z may be going forward, may be going backward, but these are the 3 things that if you trace this out, you'll see how to do that and how it's going. So those are functions. I have lots more practice with functions, but those are functions, and this is an amazing tool to get stuff done, because you break your problem into smaller problems, and you do each problem separately. You do every single problem separately, and when you do that, you're actually able to address bigger issues all at once. I will do that as examples in the practice, which is going to follow this. I will break a big problem into small problems, and I will show you lots of examples of this beyond what we just did. Okay, so really work on that.